All right, this next lesson is on similar figures. In terms of definitions, similar figures have the same shape, but are not necessarily the same size. If we're talking about congruent angles have equal measures. If two polygons are similar, then their corresponding angles are actually congruent, which means they're the same. They're equal to each other. And the lengths of the corresponding sides are proportional. What you need to know about the word corresponding is that it means they're located in the same spot. And they'll be in the same spot as long as your triangles or other shapes are oriented the same way. So in this one, triangle ABC is similar to triangle DEF. Notice they're both oriented in the same way. So what that tells me is that angle A is congruent to angle D. So if we were to actually take a protractor and measure them, they would be the same. So the angles are congruent to each other. We use congruent as an equal sign with a woo over top of it. Angle B is congruent to angle E. And finally, angle C would be congruent to angle F. So those are the congruent parts of it. The side lengths we set up here in the definitions were proportional. So this side would be proportional to this side. So AB to DE. If we talked about this side, AC, which is represented by X, that would be proportional to this side, DF. And finally, the bottom part, BC, would be proportional to EF. So now we can actually use proportions. Since we have an X and we have a Y, we're going to need to write two different proportions. So the first thing to realize is the 3 goes with the 15, the X goes with 35, and the 4 goes with the Y. I'll typically mark them with different symbols so that I can keep them straight. If I tried to make a proportion with the 4 and the Y and the X and the 35, I'm going to have two variables, so I'm not going to be able to solve it. So this 3 and the 15 side is going to be important for me to use. So I'm actually going to use that twice, because even if we find out what Y is or what X is, we don't want to use that value just in case we messed up when we did that first round. So let's go ahead and work with the X's. So I'm going to start with 3 over 15 because that's my relationship from what I call the baby triangle to the mama triangle. So 3 goes to 15, and let's do the same thing with the boxes, X to 35 then. So here you have a proportion. Solve it with the heart method. So 3 times 35 is going to give you 105. Equals 15x. You're going to divide by 15 on both sides to get x by itself. And if you do that, 105 divided by 15 will give you 7. So x is 7. So we can actually put that into our picture then. Like I said, we're not going to use the 7 over 35 though. We'll still go back to using the 3 over 15. And now we need to do the 4 compared to the y. Heart method. So 3 times y is 3y, 15 times 4 is 60. So we'll divide by 3 to get y alone, and we find out y equals 20. It's going to make sense to you because it's actually going to be proportional. If I think about this one, to go from here over to here, 3 to 15, this is 5 times the size. So what times 5 would get me over here to 35. Work your way backwards, that takes me to 7. 7 times 5 is 35, and 4 times 5 is 20. That's why we use this similar figures in our proportions unit, because they're proportional. Take a look at the trapezoids up here. First thing I always suggest is go through, find your corresponding pieces, and I mark them. So 24 and 48 are the ones that we know, so that's going to actually get us started. So then we just have to pick, do we want to work with these two or these two? Let's just go with the y's. So we have 5 over y plus 4. Now, since I picked from this guy first and then this guy on the bottom, this has to be on the top, this has to be on the bottom. We have to follow that pattern that we have there. This This is a junk in the trunk, so you're going to have 24 times the quantity of y plus 4, and 5 times 48 is going to give us 240. So this is going to be 24y plus 24 times 4 is 96 equals 240. So we're going to subtract the 96 from both sides. So we're going to get 24y equals 144. To get y alone, we'll divide by 24. We get y equals 6. Alright, so now that took care of this first one. Now we're going to have to take care of the triangles. So I'm going to still set up 24 over 48 equals 2x over x plus 12. I'm going to go ahead and put that in parentheses because it is junk. Heart method, so 24 times x plus 12 equals 2x times 48. So 48 times 2 is 96 times x. And drop a line down just to keep things pretty here. So 24x plus 288 equals 96x. So this has more x's. I'm going to go ahead and subtract the 24x to move my variable. This makes it nice because this is the constant here. And 96 minus 24 is going to give us 72x. So we'll divide by 72 on both sides. X is going to equal 4. So we found out y is 6, x is 4. So now we can actually go back. BC is equal to 2x. X was 4, so that's 2 times 4, which is really 8. FG is x plus 12, so 4 plus 12 is 16. And EH is y plus 4, y was 6, so 6 plus 4, which is 10. In the next example, we actually have what are called nested triangles. So this little triangle is inside this larger triangle here. So this 3 corresponds to the y, the 5 corresponds to the 12.5, and the 4 corresponds to the x. So we're going to actually be using this piece to get both of our proportions started. I'm going to actually just go ahead and set both of them up right now. So I went for the nested to the bigger triangle. So if I do 3, that would compare to y for my first proportion. And in this one, if I do 4, I'm going to compare it to x. So 5y equals 37.5. So we'll divide by 5. Oops. And we get 7.5. And in this one, we're going to get 5x equals, so give me 50, divide by 5. X is going to equal to 10. So this side here is 10, this side here is 7.5. And we're done.